Welcome, everybody. We are on Compound Inequalities Part 2b. All right, so I see 13. We're going to be working on 13 through, let's see what we have going. 13 through 22. Let's get going. We have x is less than 2 and x is less than 5. So I know I'm going to do it in three different colors. So I know x is less than 2. I know if it's an and statement, it's when it overlaps. And overlap means when the two inequalities, all right, so I know that x is less than 2, and I know that x is less than 5. So I know this guy's going to go this way. So my new inequality is going to be two things. I know that it's going to start here because that's when both of the inequalities intersect. And so my new compound inequality would be this. I understand that I'm going to be graphing this. This is my solution set. My solution set is the numbers less than 2. All right, let's try number 14. So the first one, maybe I want to make sure. Now the first one right here is going to be x is less than -4, and it's an or. So in this one, it doesn't matter it doesn't matter where the lines are going to cross over. So we're going to draw this one. It says x is less than -4, so I'm going to go this way. And it says x is greater than or equal to 3. So we fill it in because it is a what type of circle? Closed circle. All right, let's go on. So that's my solution set. My numbers, my solution set will be x is less than -4 or x is less than, nope. I'm sorry, guys. I misread that. It says less than. So let's erase this. And we're going to go this way. So this actually changes our answer. So I'm going to erase this part. So it starts at 3 and it goes this way. And it completely engulfs the red numbers. So it wipes away. We don't even need to talk about x is less than -4 because x is less than or equal to 3 is our solution set. Done. Next up, this is going to be a compound inequality, the and, because it's compact. It's in compact form. So I know I can just, straight up draw at -3 and 3 and connect it. And there's nothing that says, hey, anything different. So technically, my solution set would be the numbers between 3 and -3, but not include -3 and not include 3. The exact same compound inequality that's shown. All right, so now this one is going to be, do we care if they overlap or do we care where any line touches? 3, 2, 1. We don't care about the overlap because it's not an and statement. The and statements are the only ones where we care about. So this is going to go this way forever. And x is less than 0 is going to start here and go this way forever. Now, technically, since it's going to touch, both of these are going to touch all the numbers going in different directions, the solution set will change. It is not the inequalities that are there. We are going to have to state the solution set is all real numbers. Here we go. We're done with 13 through 16. So now the next ones are going to be a little bit harder because we have to solve and then graph it. I would like to remind you, I want you to try to solve it first, and then we're going to do it together. Going on in 3, 2, 1. All right, so when we try to solve it, what we have to do is we have to isolate for the x. So we have to use the properties of equality. So if I see 2x, what the 2 is doing to the x is multiplying. So I'm going to use the division property of equality in order to isolate for x. So I know that x is going to be less than or equal to 4. Now I can divide on this side. I'm going to use the division property of equality. So I'm going to divide by on both sides, the 3 on both sides. So I know x is greater than or equal to 5. So if x is less than 4 and x is greater than 5, well, that's my solution set. My solution set is going to be all numbers. So all numbers below or equal to 4, or all numbers above or equal to 5. That's it. All done. Let's continue to number 18. So now this is a compact and. This is an and because it is in what form? All right, let's go on. So we could either solve it or we can pull it apart to solve it. So we rewrite this. 2x minus 7 is less than or equal to 3. If I add 7 on both sides, I'm going to get 0 is less than 2x. And then if I divide by 2 on both sides, I'm going to get 0 is less than x. So I know that it's going to go this way. Now, 2x minus 7, I'm going to add 7 on both sides. And negative 3 plus 7, you might think it's 10. You might think it's negative 10, but it's not. Negative 3 plus 7 is what, class? All right, it's going to be 4. So 4 is greater than 2x. So if I divide by 2 on both sides, what do we get? Yeah, x is less than 2. So I know x is less than 2. Nope. It should be more than. No, I'm good. I messed up this one. That's the one I messed up. So let's erase this. We're going the wrong direction here. So this one needs to be going up forever, this way. Now for the x is less than 2, it's going to be here and go this way. Well, since it's an and compound inequality, we just connect it here and here, and now we rewrite it. We say 0 less than x less than 2, and this is our solution set right here. All right, let's go on in 3, 2, 1. All right, so or. Now, or, do we care if it overlaps or where any of the inequalities will touch? For this one, we care about where the inequalities will touch, not just where they overlap, because we don't care if they overlap, just where one of the inequality goes. So this one's already set up. So I'm going to put, oh, nope, there's a negative. So I'm going to times negative 1 on both sides, and I get x is greater than or equal to negative 2. Why? What happened to that inequality sign, and why did it happen? Listen to what I said I did. What operation did I do? All right. Yeah, I multiplied by negative 1 on both sides. And so it's going to go this way. Now, for this next one, I'm going to isolate for the variable. So I'm going to add and then I'm going to divide on both sides. I get 8. And then this is 2x. So if I divide by 2 on both sides, I would get x is greater than or equal to 4. So I would go right here, and it's going to be this way. Well, if this is the or, I know that this is this is going to go forever, and it's going to overtake this, and I don't need to have the black. I know it should just go this way. And so my solution set will be x is greater than or equal to -2. Done. All right. I'm going to do 21, and that's the last one we're going to do. And then I'm going to ask you to work on 20 and 22 by yourself. All right. So isolating for the variable, I could divide by 2 all the way across, and that will simplify my equation. If I divide this by 2, I get x. If I divide this by 2, I get -2 is less than -1. And then if I add 2 to both sides, I'm going to get x is less than +2 + 2, 1. So I kind of wanted to do this in red, but I didn't. That's fine. So it's an and statement. Do we care about where, do we care about only one line, where any line goes, or where they overlap? It's an and statement. Which one is it? In 3, 2, 1. Yeah, it's where they overlap. All right, so if I divide this, I know this, everything here is multiple of 2, so I can divide by 2 right here. So if I do that, I'll get x minus 3 is greater than -1. I can add 3 to both sides, and if I do that, -1 plus 3 is 2. So 2 is less than x. So x is greater than 2. So I know at 2, it's going to go this way. Okay, guys, it's an and statement, so they have to overlap. So where do these two lines overlap? Can somebody give me an answer in 3, 2, 1? That's right. They don't overlap. So if they don't overlap, the solution set will be no solution. There is no solution since these two inequalities do not, qualities, all right, do not overlap. All right, guys, thank you very much. I look forward to seeing you guys in class. You guys have a wonderful day. Bye, everybody.